All right, so here we come to the whiteboard. Now I'm going to start with some kind of a basic example over here, which will help you to really understand this concept of a linear regression. Okay, so I'm going to let's say I have a table over here, right? So I have a table which contains x variables and then y variables. Okay, so let me draw this over here. Okay, so I have some x variables, then I have some y variables. Now, let's say when x is 1, y is also 1. When x is 2, y is also 2. When x is 3, y is also 3. When x is 4, y is also 4, and so on and so forth. Okay. Now, let's say I want to put this one in a form of a graph. All right. Now, in that case, I can draw something like this, right? I can use the xy plane, right? So our y will be here, and then our x will be here. Okay. We can draw the xy plane like this, right? This is some basic mathematics that we know that we can draw. I mean, a plane like this, which is the xy. I mean, the xy plane, right? Xy plane. Okay, we can draw a plane like this. Now, over here we call it origin, where we can put 0 over there, right? We call this place origin. Right, let me push it a bit over here, right? We call this place origin. ORIGIN, right? We call it origin. Now, let's say that on the x-axis, we have the x variables over here, right? So x, here we have 1, we have 2, we have 3, we have 4, right, over here, and then we have 5, and so on and so forth, right? And let me actually space these things out, right? So we have 1 over here, then we have 2 over here, then we have 3 over here, then we have 4 over here, and then we have 5 over here. And on the y, we have 1 over here, we have 2 over here, we have 3, and then we have 4, right? We have 5, and so on and so forth, right? Now, from our table, right now, we are going to convert our table to a graph over here. Okay, now from our table, when x is 1, y is also 1. Okay, so when we come here, x is 1, y is also 1, so they meet over here. Okay, we have a point over there. When x is 2, y is also 2, so they meet somewhere here, right? When x is 3, y is also 3, so they meet somewhere here, right? And when s is 4, y is also 4, so they meet somewhere here, right? And so on and so forth. If we go to 5, right, we have s to be 5, and then we have y to be also 5. Okay, so we can maybe do that one as well, right, over here. Now, this is what we have over here, right? Now, we want to draw a line to cross this one, right? We want to draw a line to cross this one. So let me bring a line over here, right? So let's say I want to bring a line, right? So we want to draw a line to cross these ones over here, like that. All right. Now, this is what we have, okay? So we are able to capture as many points as possible over here. Now, what linear right between the x, right, between the x and then the y. Okay, let me choose this. We are trying to find a relationship between the x and then the y. So now we are saying that when x is let me push this a bit up. We are saying that when x, so let's say we have y over here and then we have x, right? Y is equal to x. If you see the data points that we have, right, when y is 1, x is also 1. When y is 2, x is also 2, right? In the same way. So they are all the same thing, right? All right, so we can say that y is equal to x, right? So what linear regression is trying to do is to find a perfect relationship between the y and then the x. Okay, a perfect relationship between the y and then x. Now, for every integer, right, for instance, if you pick 1 and you multiply it by 1, you're going to get 1, okay? If you pick 2 and you multiply it by 1, you're going to get 2, right? If you pick, say, 100, and you multiply by 1, you're still going to get 100. Okay, so if for any number, right, whether it's a decimal or if you pick, say, 200.005, we can assume that there's 1 multiplied by this, and also there's 1 multiplied by this, okay, which is just the same thing. 1 times y is still y, okay, and 1 times x is still x. All right, it's just the same thing. Now, if you write it this way, y is equal to 1 times x, right? 1 times x. It's still the same thing because this is just the same thing as y is equal to x. All right. So if y is 1 and we multiply 1 times x value, which is 1, okay, we're still going to have 1 is equal to 1, right? So we have not changed anything, right? Because when y is 1, x is 1, okay? And over here, when we say that we are going to multiply it by 1, we've not changed anything. When y is equal to 2 and we have 1 times the x value, right? When y is equal to 2, right? When y is equal to 2 over here, when y is equal to 2 over here, x is supposed to be 2, right? So in the same way, if we multiply 1 by 2, right, we're still going to have 2 is equal to 2, right? So we can say that our equation is the same thing as y is equal to 1 times x, okay? 1 times x. Now, we want to make this equation more general, right? We want to make this equation more general. There's a possibility that the values are not going to be the same. Like this one, I just gave a hypothetical example, and I'm saying that for each value of x, y is the same, right? And for each value of y, x is also the same thing. It's also possible that for each value of x, y is not going to be the same, okay? And in that case, we cannot multiply it by 1, all right? We cannot multiply it by 1. For instance, if y is say 1 and x value is say 3, right? In that case, we cannot say that we are going to say 1 is equal to 1 times 3. It's not going to be the same, right? Because 1 is never equal to 3, okay? So we want to make a generalization over here. Right? So instead of saying y is equal to x, we want to rather write y is equal to m x, right? So instead of the 1, we are representing it with m to get a general form, right? To get a general form. So this m could be 2, it could be 3, it could be 100 or whatever, right? It could be anything else. All right. So that's what we want to do. Now, this is the form that we have established. So let's go up here. Now we are saying that based on the table that we have, right, we have our x values to be the same as our y values. Okay. So if you come down here, okay, so we established a relationship there, and we said that y is equal to x, right? Which we have come to generalize it as y is equal to mx. Okay, so if our y is equal to 1, we expect our x value to be the same. So in this case, our m is going to be 1, right? And then multiply by our x value, which is 1. And then we're going to have 1 is equal to 1, which is perfect. Okay, now we're going to take another scenario where the values are not going to be the same, right? Where the x values are not going to be the same as our y values. Okay, so let's take another example over here. Right, so I'm going to get another table over here. So let's say we have our x values, then we have our y values over here. Okay, now let's say that when our x is 0, our y is 1. Okay, when our x is 1, our y is 2, right? When our x is say 2, our y is 3. So if you can see that for each of the x values, y increased by 1. Okay, so this one, it's increased by 1 to become 2, it's increased by 1 to become 3, right? When our x is say 3, it's going to increase. So what do you think we will have over here? 4, right? When our x is say 4, what do you think we will have over here? 5, right? Okay, now let's say this is how it is. Initially they were all the same, right? When x is 1, y is also 1. When x is 2, y is also 2, right? But in this case, we are having it in a different form. When x is 0, we have our y to be 1, right? When x is 1, we have our y to be 2, which is increasing by 1. Okay, now let's say that we want to plot this. We want to plot this one over here. So let me do this, right? And then we'll have our y over here, and we're going to have our x over here. Okay, and then we will have our origin, which is 0 over here. Okay, now in this case, when x is, well, let's actually label it. So we're going to have 1 over here, then we'll have 2 over here, then we'll have 3, we'll have 4, and then we'll have 5 over here. Then on the y, we're going to have 1 over here, we're going to have 2 over here, we're going to have 2 over here, then we're going to have 3 over here, we're going to have 4 over here, we're going to have 5 over here. Okay, so let's say this is what we have. Right now we want to plot it. Now in this case, if we plot this one, when x is 0, right, when x is 0, or y is 1. Okay, so we're going to have 0 and then 1, so that point is going to lie here. Okay, and when our x is 1, we have our y to be 2. So we have 1 and then 2, which is going to be somewhere here. Okay, when our x is 2, our y is 3, so it's going to be this way to be somewhere here. When our x is 3, our y is 4, so it's going to be this, and let's say somewhere here, right? When our x is 4, our y is going to be 5, so it's going to be somewhere here, right? Something like that. Okay, so this is what we have. Now if we try to bring the line, right, so let me go here and bring some line over here. If we try to put a line over here, right, so that's going to be something like this, right? Capture as many points as possible. Okay, so this is going to be our line. Okay, this is going to be our line over here. This is going to be our linear regression line. Now you can see over here that in this case we did not touch the origin, did not pass through the origin. Whilst initially we were having this, right? In this initially we're having this one. So if we want to extend this one, it's going to pass through the origin. Okay, this one is going to pass through the origin, but this one is not going to pass through the origin, but it's going to pass a value over here, right? It's going to pass through this value over here. Okay, now if we bring our equation here, right, which the general equation that we established earlier on, right, which is y equals mx, right? If we bring it over here and then we write it over here, y is equal to mx, right? This is what we established earlier on. Now if we try to use this equation, right, for this, initially we're saying that the m represents 1. So in this case, if we say that, okay, y value is x value, right, x value here is 0, right? So if x value is 0, and then we say that y value is 1, right? Now it's going to be 0 times 1, and 0 times 1 will not give us the y value. We are supposed to get 1. Okay, in this case we're going to get 0, which is not the case. Okay, which is not the case. In this case, when x is 0, we are supposed to get y value to be 1. Okay, so this equation alone will not work. One, and we multiply by 1, we're going to get the y value to be 1. Okay, which is the same thing over here, right? If x value is 2 and we multiply by 1, we're going to get the y value to be 2, which is what we have in our table. But in this case, it's not going to work, right? If x value is 2 and we multiply by 1, we're going to get 2, right? But in this case, if x value is 2, we are supposed to get 3, right? But in this case, if x value is 2 and we multiply by 1, we're going to get 2, which doesn't work, right? Now what if we introduce another thing over here, right? Let's say we add 1 to it. Okay, what if we add 1 to this equation over here? Now in that case, if x value is 0, when we multiply by 1 and we add 1 to it, that will give us the perfect one. Okay, if x value is 2 and we multiply by 1 and we add 1 to it, we're going to have 3. Okay, we're going to have 3, which is what the value over here. When x is 2, we are supposed to get 3 for the y. Okay, and that is going to give us a perfect relationship, right? You see that here we are able to establish that relationship. So we can modify the equation to be y equals, instead of just mx, right, we're going to add 1 to it. Okay, and then it becomes y equals mx plus 1. Okay, now this is so far what we have established, y equals mx plus. It's also a case where if you add 1 to it, you're not going to get the y values, right? Now what if we, instead of, just like we generalize the 1 over here, what if we generalize this 1 too, right? And instead of this, we make it y is equal to mx plus c, right? So that the c figure out that relationship, and that, so this c could be 2, it could be 3, it could be or whatever, right? We don't really know, so we make it general over here, right? And this, right, this that we have been able to establish, this is the equation of a line. Okay, this is the equation of a linear line, or equation of a line, to be simple, right? This equation of a line, y equals mx plus c. Okay, Now this, if you see what we did, right, we added 1 to it and it worked, right? This one is nothing but, if you go to this curve, right, this one is nothing but where the line was cutting the y-axis, okay, where the line was cutting the y-axis, right? Well, that's what we were having 1 over there. So we call this one the y-intercept, right? This one that we've put over there, we call it y-intercept. That is where the line intercepts with the y-axis. Okay, that's where the line cuts the y-axis. So we call it y-intercept. Okay, in some other cases, right, the line could be something like this, and then it will cut it at 3, right? So in this case, the 3 would have been the y-intercept. That's why we want that thing over here to be general. Okay, so this C is referred to as y-intercept. Okay, it's nothing but y-intercept. M over there, right? M over there. Let's go up. The M over there is representing the change in X with respect to the change in Y. Okay, so for instance, in this case, if S changes from 1 to 2, right? It changes from 1 to 2, right? What will be the change in Y? Okay, what will be the change in Y? So we can measure that change, right? So we can measure it based on the point over there, right? So I can trace it, just the same thing. I can trace it over here, right? So when X changes from 1 to 2, right, Y also changes from 2 to 3, right? Y changes from 2 to 3. You can see that from the table, right? When S changes from 1 to 2, Y changes from 2 to 3, right? So what is the relationship over here, right? When 1 moves by 1 point, that is the change from 1 to 2, right? It's just like 2 minus 1 is going to give you 1, right? X also changes from 2 to 3, which is like 3 minus 2, and that is also 1. Okay, that is the change that they have, right? So if you see on the graph, this is how we measure it. It's going to be the change. We use this delta sign over here, change in X, and then here is going to be the change in Y. Okay, the change in Y over here, right? And that is what is represented by the M, right? We refer to that M as slope, right? That is what we refer to it as slope. So later on, if you hear me saying slope, right, all I mean is the change in X with respect to the change in Y. Okay, the change in X with respect to the change in Y. And we represent the slope like this. So we say that it's change in Y by change in X. We're going to have change in Y by change in X. Okay, so initially we have change in Y, right? So the initial Y value was what, 2, right? And then it moved to 1, and then the second value, that is a change that came by, say, Y2. Okay, which is going to be the same thing as this Y2 minus Y1. Okay, and then the X, right? The X, it changes from 1 to 2, right? So we're going to have X1 over here. We can represent this one by X1, then this one by X2. Okay, it will give us over here as X2 minus X1. Okay, and that is going to be like this. So Y2 over here is going to be 3 minus 2, right? Just like we saw over here, 3 minus 2, okay, which gave us 1. So we're going to have 3 minus 2 over here divided by, and then X2 minus S1, which is nothing but 2 minus 1. So it's going to be 2 minus 1. And 3 minus 2, we got 1, by 2 minus 1, we got 1. Okay, and then 1. So this is what is referred to as what, the M, right? So our M here is now equal to 1, right? Which is the slope, right? That is how much Y changes with respect to the change in X. Okay, right? How much thus Y also changes. So in this case, when Y changes by 1 unit, X also changes by 1 unit. Okay, and that becomes the slope that we have over here, right? That becomes the slope. So this M is referred to as what, slope, right? And then the C is referred to as the y-intercept, which is nothing but where the line cuts the y-axis, right? Which in this case cut it at 1. And then I said in other cases can cut it at different position, right? That's why we are generalizing it and giving it C instead of say 1. Okay. So I urge you to just re-watch this video, right? And then I mean, just in case you missed something, just watch it one more time, right, to get a better understanding of it. Okay, it's just a short one. I mean, just take another time to watch this again and then get standing over here, right? Before you even move on to the next lesson. All right.